sodium and chloride, okay? So a lot of those metabolic wastes, along with some of the toxins and drugs, hormones, excess hydrogen, which we'll talk about here in just a few minutes, okay? Now let's talk about the anatomy of the kidney. So this is what our kidney looks like. And again, in the lab, you're going to discuss this at length. So I'm not going to spend a huge amount of time on it. But I do want you to know the basic component pieces of them. So here we go. Size and position, generally posterior to the abdominal wall, T12 to L3. Right kidney is slightly lower because of the liver, and they are considered to be retroperitoneal, along with all of the other organs, the ureters, the urinary bladder, renal artery, renal vein, adrenal glands. Okay. Now we're going to go through all of the parts and pieces. So here is a look at them, and what I'll do is we will look at one diagram that's much larger in size, so that you're not having to struggle with trying to pick these out because they're a little bit small. This presentation, by the way, will be up on Blackboard in that folder, so you can go and you can reference it this at any time so that you can take a look at it. Okay, real quickly, number one, kidneys. Number two, see that stuff right there? Perirenal fat. And somebody once upon a time was like, oh my God, look at all the fat that's there. Absolutely. We have to have all of the fat that's there. Why? Protection. Remember, this is retroperitoneal. It is not far from the posterior aspect. And so trauma from the posterior side could do a lot of damage. Also, just the regular old gravitational force, the jumping up and down. So you'll see that this perirenal fat is very protective. Number one. Number two, it anchors. Number three, if we have to, it could be a nutritional source. Okay. Here's our renal capsule. The renal capsule, think of it as a leather coat. Remember, a lot of our structures have that very heavy duty fibrous protective coating. Same with the renal capsule. Okay, very fibrous in its nature, very heavy duty, protecting what's underneath. Number two is called the hilum. The hilum, you'll see in a couple of different structures. We saw it in the lymph nodes. We now see it in the kidney. It's basically the area in which you have all of the vessels and all of the vasculature, all of the component pieces of that organ entering and exiting out of. Okay, and so what you see, number one right here, is probably the renal artery because it's not dyed correctly. I can't be 100% sure, but my guess is that is the renal artery. That right there is the ureter. And so that area that enters and exits out of that hilum directly into and out of, allowing for transport of materials and removal of waste. So here we go. Just like the adrenals, this area is split into two very distinct component pieces. And we're going to talk about what's found in each of these. They each have very specific functions that need to be taken care of in those areas. So around the exterior portion or superficial, this guy's called the cortex. In the cortex, you're going to find most of the nephrons existing. And again, the nephron, and we'll get to it, the nephron is the functional unit of the kidney. You have more than 1 million of them per kidney, and they are what is separating off that blood plasma to send it through a filtration device to clean it and remove a number of materials, but most importantly, nitrogenous waste. There is the medulla, so inside. So you're looking at these guys right here. Cortex along the exterior, medulla on the interior, feeding down into these little triangulated structures called pyramids. We'll talk about what's found in the pyramids and what they do. And look, they look very striated, don't they? Does it make sense that you might have a bunch of tubing, pieces of tubing that create that very textured look? In between, so this area right here in between the pyramids are called the columns. So you've got pyramids, columns, and these little funnel-like structures. on the bottom, right here. Let me go back just so we get to take a really nice look at them. The little point at the bottom is called the renal papilla. The renal papilla, renal papilla, renal papilla. And basically it's the collection point of the pyramid so that all of that now urine-based material can drain into one location. So renal papilla into this guy right here, and let me switch so that we can take a look at it, called minor calyces, onto the major calyces, into what's called the renal pelvis, and onto the ureter. And I'll show you in a little larger visual. The nephron, located up here in the cortex. The nephron is where we will find the functional unit of the kidney. This is where the filtration takes place. After all the filtration takes place, it begins to, it's collected and all shuttled into one area right here. By the time we get to this point, it is urine. This renal pyramid will drain all of those nephrons into one location called the renal papilla. The renal papilla then will funnel all of the collected waste into this guy right here called the minor calyces, into the major calyces, into this thing right here called the renal pelvis. And the renal pelvis is sitting right at the hilum, right? The hilum is the opening. So this right here is the renal pelvis, collecting all of the fluid from all of these different areas of the kidney, one collection point, so that we can then, excuse me, remove that waste down into the ureter. Again, real quickly, this just lays out all the parts and pieces for you. So if you're having trouble finding the structures, there they are. Cortex, all of this large area through here, medulla, each one of these little individual triangles, a renal pyramid. The papilla is the collection point for the pyramid. This is the minor calyces. This is the major calyces into what's called the renal pelvis, and then onto the ureter. Okay. The other thing that you see is the major blood supply that's running through here, and we're going to talk about that in just a minute. How do you filter blood if you don't have good blood supply to the kidney? Can't. Okay, so we'll talk about that. This is what's called renal circulation. Now, I'm not going to mandate that you know the very smallest of the arteries that are here. However, I do want you to see the distribution of that blood supply. Sorry, there we go. I want you to see the blood distribution into the kidney so that you can see how extensive it really is, okay? So we start with the renal artery entering into that kidney, and then we begin to distribute it through all these what they call segmental arteries. And again, I'm not going to require that you know the names of the arteries, but look at the vast distribution that occurs into these what they call interlobular arteries, and then what are called the arcuate. And you'll see that they sit just above those pyramids because we're going to deliver blood to the filtration device. The filtration device will filter and remove that waste. And then we're going to send it right back through this pyramid and into this system to exit out. Okay? Here is the return pathway. And so what you have are the arcuate veins returning blood back into the interlobular veins, into the segmentals, and then back to the renal vein. Okay? Here is the pathway. There is the distribution of them, and look at all the blood supply that's up there in the cortex. Again, the blood supply in the cortex is there to deliver blood so that that blood plasma can be separated off from the whole blood, filtered, and then returned back to the blood vesseling system. And so what you see is from the aorta to the renal artery to the segmentals, interlobulars, arcuates, radiates, and to the afferent. Now, this will become key. We will talk about this, and I will draw it on the board for you. It's called the afferent arteriole. And we know that the term afferent means to arrive, right? So this is where the blood is going to arrive at the nephron. I promise you I will put it up on the board. You will see it a number of times before we're done today. That afferent arteriole feeds directly into what's called a glomerulus. A glomerulus, and look, it's purple in color. Why would it be purple in color? capillary bed. And the capillary bed is what's separating off the blood plasma from the whole blood. Those red blood cells and white blood cells are too large to pass into, or should be too large to pass through that glomerulus. The glomerulus is a ball of capillaries that will separate out the blood plasma from the large red blood cells and white blood cells that should not be able to travel through that system. Okay? Blood coming out the other side through that efferent arteriole. Efferent means to exit. So coming out of that nephron through the efferent arteriole, again, purple in color, into the radiates, the arcuates, the interlobulars, into the renal vein, and back to the inferior vena cava. Okay, so that is the pathway of the blood from the heart to the glomerulus and back to the heart. And again, there are more than 1 million of these individual nephrons found per kidney, which means that there are 1 million, There are 1 million of these little glomerulus per one kidney, okay? We need to talk about the types of nephrons that you will find and the distribution of them. There are two major component types of nephrons. And again, the nephron is the functional unit. I will show you in just a minute what the nephron looks like. This is the little ball of capillaries that will filter or pull off that fluid to begin the separation of the plasma. And what you find are these tubes that are all connected to that ball or the filtration device. But what I want to show you, do you see the extensive blood supply? And we'll talk about why such an extensive blood supply. These guys are called peritubular. Peri means around the outside. Two trailer park girls go around the outside. Peri, okay? Peri means around the outside of this nephron. And what you find is it's surrounding these guys up here. We haven't gotten to the, we haven't broken down the pieces of the nephron, but they're called the proximal convoluted tubule and the distal convoluted tubule. And I'll show you what they look like in just a minute. So type number 1 is called a peritubular capillary, and it's found up here in the cortex. And it's taking care of the reabsorption of a lot of the materials from the blood plasma that we want to be able to recycle. We don't want to get rid of all the stuff that's in the blood plasma, especially not the water. Okay? So we know that 99% of the water in these nephrons will be reabsorbed, but other things get reabsorbed as well. We want to reabsorb some of the glucose, some of the minerals, sodium, potassium, calcium, magnesium. We don't want to lose those. So a lot of reabsorption takes place in these capillaries, and I'm going to show you a better visual when we talk about urine formation. The second type of capillary system is found in the medulla. So here's the cortex. This area down here is the medulla. And look, really, really, really long nephron tubes, okay? This guy is called the nephronic loop, or the loop of Henle. See how short it is? See how long this guy is? On the very long loops, and we'll talk about them in just a minute, we'll call them juxtamedullaries. In the really long loops, or the juxtamedullaries, you have an extensive blood supply, but see how loosely knit it is and how it's covering the whole nephron loop, where it does not cover the nephron loop over here in the peritubulars. So in the juxtamedullary nephrons, with the very long loops dipping into the medulla, this vesseling system that serves this nephron loop is called the vasa recta. And the vasa recta is key in helping us reabsorb 99% of the water content of that blood plasma that's now called filtrate. Okay, so we'll talk about exactly what the terms are as we go. Okay, let's talk about the nephron. After this, I will show you on the board the pathway from the nephron all the way to the exit, basically, okay? So you have more than 1 million nephrons per kidney, and there are two parts to it. Number one is called the renal corpuscle. This is the filtration device, and we're going to get into heavily and break down the parts and pieces of that filtration device. The second is called the renal tubule, and this is where we'll find the conversion and the reabsorption of a lot of material, and what's not reabsorbed and eliminated as waste product is in that renal tubule. The corpuscle has two parts to it: the glomerulus and the capsule that surrounds it. The glomerulus is a capillary bed. What did I say capillary beds did? They deliver nutrient and remove waste, okay? So with this particular glomerular bed, it is a capillary ball of capillary, or a capillary network, and because of the hydrostatic pressure, it is pushing out blood product. However, there are, and we'll talk about this, I'll show you pictures, there are little barriers inside that glomerulus that create a filtration and only allow certain sized materials out into the capsule. And it's a way to control what is being eliminated from the blood. Blood cells, leukocytes and erythrocytes, are too large to be able to move through that barriered system. Therefore, they get rotated back into the whole blood, while the rest of the liquid